In this video, we'll be looking at solving systems of linear equations using the substitution method. To solve for a system of linear equations, we are looking for where multiple linear equations intersect, or where they have the same values. Let's look at this example. In substitution, we are looking at substituting one value of a variable into another equation in order to solve it. Because in our first equation, x is defined as 2, we can just substitute the x in the second equation with 2 because it is equal to the same thing, which simplifies to y equals 7. This means that our solution is 2, 7, since x equals 2 and y equals 7. Let's look at another example. Y equals 3x minus 5 and y equals negative 2x plus 15. In this case, both equations are equal to y. This means both equations are equal to each other. That means that we can substitute the value of y in the second for the value of y in the first, and it looks like this. Now we can add 2x to both sides to combine our x's on one side, which gives us 5x minus 5 equals 15. Now we can add 5 to both sides, which gives us 5x equals 20. Divide both sides by 5, and we get x equals 4. Now we can use that definition of x, 4, to substitute it back into one of the original equations in order to solve for the second variable. So in this case, we'll put it back in where the x was in the first equation, and we get y equals 3 times 4 minus 5, which simplifies to y equals 12 minus 5, or y equals 7. The solution to this system of linear equations is 4, 7, because both equations are true when x equals 4 and y equals 7. Here's a look at another one. In order to begin, I'm going to try to figure out which would be the easiest variable to solve for. In this case, it looks to me like x would be the easiest. I can find a definition for x by simply subtracting 2y from both sides, and I get x is equal to negative 2y plus 5. Now I can take this definition of x and substitute it into the second equation, and now just solve for y. So I will begin by multiplying everything in the brackets by 3, and I get 4y is equal to negative 6y plus 15 plus 15. I can combine the 15s to get 30. I can add 6y to both sides, which will give 10y is equal to 30. Divide both sides by 10, and I get y equals 3. Now I can take that value of y equals 3 and replace the y in the previous equation with the value 3 because y is equal to 3. So I can bring it down, replace the y with 3. I get x is equal to negative 2 times 3 plus 5, which is the same as x is equal to negative 6 plus 5, or x is equal to negative 1. My final solution is negative 1, 3, because both equations are true when x is equal to negative 1 and y is equal to 3. Let's look at a word problem. Tennyson has $5.35 in his collection of dimes and quarters. If there are 34 coins altogether, how many dimes are there? So we can create two equations here. Q plus D equals 34 because the total number of quarters and dimes is 34. Then we can create our second one by looking at the value of the coins. The value of the quarters is the number of quarters times 25 cents. The value of the dimes is the number of dimes times 10 cents. And the total value of all of the coins is 535 cents. In this case, I'm going to solve for Q, for the quarters. I can do that by just subtracting D from both sides of the first equation. Now that I have a value for Q, I can substitute it into where the Q is in the second equation. And then I can multiply everything in the brackets by 25, which gives me 850 minus 25D plus 10D equals 535. I can combine the D's, negative 25D plus 10D gives me negative 15D. And I can subtract 850 from both sides, which gives negative 15D is equal to negative 315. When I divide both sides by negative 15, I get D is equal to 21. This means that there are 21 dimes. And the original question was how many dimes are there? there are 21 dimes. Now to review, we want to solve for one of the variables in one of the equations, use that definition of the variable to replace that same variable in the second equation, and solve for the remaining variable. Once you have found the value of that variable, use it to solve for the remaining variable.